So what I'm going to propose today is a measurement system that uses the smallest possible meaningful increments of each of the four primary dimensions as its base one measurement. And since measuring anything in our reality would reduce to some variation of the primary dimensions, the only thing that you can reduce these fundamental aspects of our reality further is by breaking them into their smallest meaningful chunk. Not that there's anything wrong with using the kilogram, the ampere, the meter, or the second, but if we were to be honest with ourselves, their values are kind of arbitrary. But even what I'm going to propose today is a little bit arbitrary, but if more precise measurements of what I am doing would be done, it wouldn't take much to change the first number in the system. This is to present the logic of the system that was started by Max Planck, but never properly completed. But enough reminiscing and backtalk, let's just jump into it. Let's start with time's smallest chunk, because it is kind of needed to begin calculating everything else. The smallest meaningful time award goes to the Planck time. The math that went into it is kind of complicated, but you can know that it's the amount of time that occurred between the Big Bang at t=0 and the time where our best predictive measurements, or best predictive calculations for the phenomena that happened at the very beginning of the universe stopped working. So essentially, we do not know what happened in the very first Planck second, but we can predict what happened between the second Planck second, third Planck second, all the way till now. And this value for the Planck time is 5.3912476 times 10 to the negative 44 seconds. And this would be the base one value for quantum time in this system. For length, I know I've said this a couple of times already, but in dimensionalism, 0 is the base space. That is at least what I proposed to take dark energy's expansive force into account. And 0 could also be the base for time, electric current, and mass too with that line of thinking. However, even if this is the case, it still is not the smallest meaningful length. The smallest meaningful dimensional length, that award goes to the Planck length. To calculate the Planck length, we can transpose the value of Planck time to replace the second in the speed of light, and calculate the Planck length by making the speed of light equal to one length over one time. The Planck length is the smallest space a photon can travel to causally affect the next patch of space in the smallest span of meaningful time. This value comes out to be 1.61625518 times 10 to the negative 35 meters, and would be the base one value for quantum length in the system. For mass and electric current, I had to get a little bit creative. Well, what I mean is, Planck mass doesn't really give us the smallest meaningful mass, and the Planck charge and the elementary charge doesn't really give us the quantized values for the quantum electric that we're going to be looking for. So here's my proposal for the quantum electric value. I calculated the quantum electric by first taking the amount of charge in an entire down quark, which is 1/3 the charge of the elementary charge. I then took that charge and I believe I calculated the amount of charge that would happen within a cubic Planck length's amount of space within the down quark. Of course, I assumed that there was equal distribution of charge within the down quark. And if there's any mathematicians in the audience, could you please do me a giddy and double check these numbers for me? The value that I got and used for this video is 1.1088 times 10 to the negative 40 coulombs for the quantum electric charge, which would give us the same value in amperes for the quantum electric current. And I know the logic in the data is there to calculate this. I'm just not sure if I calculated it correctly and most precisely. This value is dependent on the volumetric size of the down quark, and I assumed it to be 0.7126 cubic Fermi. This would be the base one value for quantum electric in the system, heavily assuming that I mathed correctly, due to change by Dimensionalism 2.0. For quantum mass, I believe the mass of the lightest electron neutrino would work best. The range for the value, even just a couple of months ago, had a fairly large and uncertain range, but the value is definitely somewhere in the times 10 to the negative 37 kilogram range, because both of the extremes, even at the time, were at that level. But a value with 95% confidence rating of 2.14 times 10 to the negative 37 kilograms came about since I last checked a couple of months ago. So, yay science! To be consistent, I tried to look into it and see if I could possibly break this value down further by distributing it amongst the value of the size of the electron neutrino. But as of my most recent internet searches, this cannot be done at the moment. I got this segment, what I'm about to tell you, from the electron neutrino Wikipedia page concerning its size that I'll share with you right now. So standard model neutrinos are fundamental point-like particles without any width or volume. Since the neutrino is an elementary particle, it does not have a size in the same sense as everyday objects. Properties associated with conventional size are absent. There is no minimum distance between them, and neutrinos cannot be condensed into a separate uniform substance that occupies a finite volume. So this value of 2.14 times 10 to the negative 37 kilograms for the electron neutrino mass will be the value of quantum mass for now, until either 1, there is a particle found that appears even lighter, so if groundbreaking physics was to be discovered, or 2, if the particle is capable of being zoomed in on enough to be capable of being observed in its true point-like state in relation to the Planck length. Then the mass contained within the volumetric Planck length amount of space would further quantize that value. Now, if we amplify each of these units by a factor of tredecillion, or 10 to the power of 42, calculating things off of the originally subjective units of the meter, kilogram, ampere, and the second, measuring phenomena using the secondary dimensions would be very easy. The speed of light, base velocity, would be reducible to 1 Planck byte divided by 1 time byte, and everything slower than that would be relative to the cosmic speed limit. And I assume that this would make base energy reducible to 1 mass byte times 1 length byte squared divided by 1 time byte squared. And all of the other base secondary dimensions would be similarly easy to calculate. And not just at the byte level, but at every equivalent increment on the scale. So it's not just like the speed of light is 1 length byte divided by 1 time byte. It is also 1 length bit divided by 1 time bit, or the Planck length divided by Planck time. The key here is that all of the smallest units of the dimensions need to be synchronized so that their growth and decay patterns along each of the dimensions can be observed as independent variables. Not that we don't already do that, but doing so would be way easier in the long run over the eons. I'm just saying, trying to remember the speed of light as 1 length bit divided by 1 time bit is a whole lot easier than trying to remember 299,792,458 meters per second. I'm just saying. So in the system, base 1 is called quantum melt, because when we say which dimension specifically, we would say quantum mass, or quantum electric, or quantum length, or quantum time. If we multiply those values times 10 to the 21st power, those are called melt bits. And multiplying quantum melts by 10 to the 42, I've already said, are called melt bytes. Bits and bytes being inspired by our computer terminology. Spacing them out this way can allow for naming the thousandth, the millionth, and the billionth places in both directions relative to the melt bits and the melt bytes, and seamlessly transition from the quantum realm to the bit realm to the byte realm with no terminology overlapping. Here on this board is the naming of the places around the byte. The melt byte again being the quantum melt times 10 to the 42 power. The negative billionth place, or melt byte times 10 to the negative 9, I've left alone and didn't change, would be called the nanomelt byte. The negative millionth place, or melt byte times 10 to the negative 6, is a new term that I called the fractomelt byte. And the negative thousandth place is also a new term that I called the partomelt byte. My reasons for naming them this way and deviating from the prefixes of micro and milli is because 1, there are too many m's in the old system, and 2, milli sounds a lot like a millionth, and why are we going to try to confuse people that way? by saying a milli is only a thousandth and not a millionth. 3, I made it so that all of these smaller places end with O and all of these larger places end with A for consistency and learning purposes. 4, every prefix starts with a different letter, N, F, P, K, M, G, to make all abbreviations unique. And 5, a parto sounds bigger than a fracto, so I made it bigger. For the positive thousandth place, I just changed the last letter of kilo to kila to make a kilomelt byte. For the positive millionth place, I kept the mega to make a megamelt byte. Sounds delicious. And lastly, for the positive billionth place, I kept the giga to make a gigamelt byte. And over here are some of the examples of the approximate values of what we would probably be using, most likely. So 1 nanolength byte is about 0.63 inches. 1 fractomass byte is about 0.47 pounds. 1 electric byte is equal to about 110.8 amperes, and 1 kilotime byte is about 53.912 seconds. So almost a minute, but not quite. Well, hopefully I didn't look too much like a mad lad in this one, devoting mental energy to a measurement system that probably no one but me is ever going to be using. But hey, there are worse things that I could be doing with my time. If you stayed till the end of this video, good for you. That's probably because you fell asleep. And sleep is good. Shh. Hey, when you wake up, please do me a kitty and click on those like and subscribe buttons. I promise videos will be more interesting than this one in the future. Next time I'm going to upload the final part to this Dimensionalism 1.0 playlist, where I'll go over some relative truths that will possibly help keep your mind healthy and grounded in reality. Sweet.